This video is going to be about zeros, multiplicity, and the fundamental theorem of algebra. Now, we already know that real zeros are the same thing as x-intercepts, so that's just a little reminder. Every time I talk about real zeros today, think x-intercepts. Now, the fundamental theorem of algebra allows us to look at an equation and know something about the graph instantly. The fundamental theorem of algebra says that the degree of the polynomial tells us the maximum number of real zeros that are possible. In other words, if we have a degree of 3, then there are a maximum number of 3 real zeros. Now, maximum meaning that there could be less. So there could be 2 or there could be 1. All right, it's the maximum number. A degree of 4, we could have 4 real zeros, 3 real zeros, 2, 1, or none. I left off my 0 up here. Remember, we can have all imaginary zeros, okay? So that's what the fundamental theorem of algebra tells us. It lets us know instantly the maximum number of zeros we might have. So given f of x is 4x squared minus 9, my degree is 2. So I could have 2 real zeros, 1 real zero, or no real zeros. Let's check the graph. Here is the graph. I have a real 0 here and a real 0 here. Now remember, the 1 0, it could have touched the x-axis just once. The 0, it could have touched it no times. So that's how it can look to satisfy all 3 of those situations. Here is g of x equal x cubed plus 5x squared plus 7. The degree is 3. So I could have either 3 real zeros, 2 real zeros, 1 real zero, or no real zeros. Okay, so let's look at its picture. So here is our graph. We have 1, 2, 3 zeros. Again, that's the maximum. There's no way this graph could move so that it crosses the x-axis 4 times. All right? Okay. In factored form, we know that the factors give us the real zeros. So here we know we have a real 0 of negative 3 and a real 0 of positive 4. Okay? Now, that's 2 real zeros. What's the degree of h of x? Well, remember that when we look for a degree, we need it in standard form. We don't want to have to distribute this whole thing out. So what we need to remember is that to get the first term of a standard form equation, we multiply our variables in our factors. So x times x is x squared. Well, the degree then would be a 2, so the maximum number of real zeros I can have is 2. Go ahead and put h of x in your calculator and check that. Okay, for h of x, we can see that we have real zeros of negative 2, another negative 2, and a positive 3. Now, by doing what we just did on the last example, if we distributed and multiplied all of our variables, we would get x cubed. So my degree is 3, and that means I could have a maximum of 3 real zeros. Now, put that in your calculator and check it. Do we have 3 real zeros? We don't have 3 real zeros, we only have 2. There's 1 here, and there's 1 here. So we set up here that we had 3. Well, negative 2 and negative 2 is the same number. At negative 2, instead of crossing the x-axis, it what we call bounces off of it. This is what we call in Algebra 2 multiplicity. So right here, the x value, the 0 of -2, has a multiplicity of 2. Why is the multiplicity 2? Because there's 2 of them. Okay. The multiplicity of the 3 is 1. Now, we could write h of x as h of x equals x plus 2 squared, because there's 2 of them, right? Times x minus 3. Now, when it's written this way, the multiplicity is the variables of each factor. So even-numbered multiplicity bounces off of the x-axis, and odd-numbered multiplicity crosses the x-axis. So let's do an example. Okay, the degree of g of x is 3 plus 2 plus an understood 1, which is 6. And so therefore the maximum number of real zeros is 6. So then when we look at the actual factors, I have a 0 at positive 6, and its multiplicity is 3. Then I have a real 0 at positive 1, and its multiplicity is 2. And then I have a real 0 at -2, and its multiplicity is 1. So since 3 is an odd number, we will cross the x-axis at 6. The multiplicity of 2 is an even number, so we will bounce off of the x-axis at the x-intercept 1. And at -2, it's an odd number multiplicity, so we will cross again. Put that in your calculator, g of x in your calculator, and see if this happens. That is the fundamental theorem of algebra, multiplicity, and your zeros.